Hi, I'm here to talk about the prototype ADS Labs VAO semantic browser, or the VAO Explorer. It's a Google-like application for browsing publications, objects, datasets, regions of the sky, and making searches on these. It exposes the links, furthermore, between publications and objects, publications and datasets and objects, so that you can see at a glance what is known or what is not known about a subject, about a dataset, about a part of space. Who is this application for? It's for working astronomers, especially graduate and undergraduate students, but it's also for bibliographers, program managers, and funding agencies, since we can link stuff to proposals and figure out the efficacy of proposals. Perhaps the best way to explain this application is by showing you how it works. On the right side is a list of papers, and on the left side is a list of facets that you can filter these papers by. You are probably familiar with faceting from websites like Amazon.com and Patagonia.com, where you make selections. You may want books which are only in French. Amongst French books, you may only want romance novels, and so on and so forth. Uh, the facets in astronomy, of course, are fairly different. On the left side here, we have some publication facets such as keywords, authors, paper types, some object facets such as object types and names, some data facets such as missions, observation types, data product types, wavelengths, instruments, targets, arrays, decks, observation times, exposure times, observation IDs, and even some proposal facets such as proposal types, PIs, and so on and so forth. Consider that you want to study the Hubble Deep Field. So we go down to the targets facet, and we choose stuff which is from the Hubble Deep Field. Furthermore, consider that we only want newer observations. This filtering got us down to 10, but if we go back and try and filter by observation time, let's say we just want stuff after some point in 2001. So let's move this facet up. There we go, it's April 2001. This reduced the number of papers to 8. Now, let's filter these down further. Let's say we're only interested in AGNs. So we go down to the Objects filter, and we click on AGNs. You notice there's AGN candidates too. In a future version of the application, you'll be able to choose both of these together. We've now gone down to 4 papers. We look at these 4 papers. Notice that the first one seems like it has something to do with the catalog. So does the third. So does the fourth. So it seems that this selection of ours is going to get us to catalogs and might get us to some interesting data. So at this point, we could either save our search by clicking on the Save Search button and save this entire search, or we could click on Get Data and get all the data. We could furthermore either just save an individual paper into our account, or we could save the data from the individual paper into our account. If we want to know a little bit more about this paper, we can click on the More tab. The More tab will give us the objects which are associated with this particular search. And it also tells us about the data sets associated with this particular search. We can click on a particular object and look for it on the CDS webpage. Or we could click on a particular data set and look at it on the Chandra webpage. So we have multiple choices of workflow. We can either get the data and do something with it, we can save our searches, or we can go off to other sites which will give us more information. Let's see another interesting example of the use of this application. Let's say I want to learn something about CFERTs. I could go down to the Object Types tab and look for CFERTs, but I can just as well type it into this area and I get a whole bunch of selections. Let me choose CFERT2s. And we've filtered our set down to 234 papers. And let's see who's been the most prolific author. There are two of them. There's M. Hardcastle and D. Worrell. Let's go down further to the proposals that went into Chandra for looking at secrets. We go to proposal types. We have the section Chandra, active galaxies, and quasars. That makes sense. And we look at the proposal PIs. We have 13 of them from Gamira Gordon. We only have 5 from Martin Hardcastle, who I assume is the M. Hardcastle in the authors. These connections are part of the work that we need to do. Steve Murray has 21 of those. Well, let's go and see the ones that Steve Murray proposed. That led to 21 papers. Of those 21 papers, if we go back to the authors, we see that Steve Murray wrote 9 of them, at least. But M. Hardcastle wrote 7 of those. So we very clearly see that data which has been taken on the basis of proposals by other people is also used by other authors, and a lot of interesting science gets done this way. So if you are a program manager or a person who is doing funding or so on and so forth, it's rather interesting to see how proposals have led to different sorts of research. The VO Explorer is built to be an extremely fast application by maintaining a single index rather than a federated set of indexes. It is built to leverage curation efforts that have been ongoing at Chandra, MAST, the CDS, the ADS, and elsewhere. And we are ourselves doing a lot of painstaking curation of data so that the results that come back from the application make sense, are not duplicate, and so on and so forth. The application is also built to standards such as OWL and SCOS from the RDF world, OPSCOR and TAP from the VO world, and the Common Astronomical Object Model, the CAOM. The application is built on a semantic database so that complex questions may be asked of the datasets, and all this functionality is exported via web services so that other applications in the VO and elsewhere can make use of the infrastructure. Let's see another interesting example. First, let's remove all our selections so that we get back to the pristine state of the application. Now, let's say we're only interested in the mission that will come from MAST. And so let's go and click on MAST. In this particular prototype, we only have stuff from HUD. That's why you'll only see the ultraviolet wavelength over here. Let's say further that we are only interested in relatively new observations from HUD using the second generation instrument. So let's click on Astra 2 HUD, which is the second generation instrument. We've now reduced the papers even further down to about 22 of them. Let's say furthermore that we're interested in supernovae, and let's go to the targets. And we want supernovae 1006, which has only 2 papers. So we get to these 2 papers, we can get the data from these 2 papers, we can save searches as we did before. But it somehow occurs to us that maybe the HUD instruments earlier went and took a look at this particular supernova. So let's go back to the current selection area, and let's X out the instruments selection. And now we see that we still only have 2 papers, which tells us that there was no data taken originally for supernova 1006. So in this way, you can browse up and down the data space, the publication space, the object space, in many different ways, and come up with interesting filters and subselections of the data that are interesting to you, at which point you can save your search or download your data. We have built this application to capture the provenance of the entire astronomy lifecycle. So far, we have developed the Publications tab, and we have developed astronomy vocabularies to capture the process of astronomy. We've loaded some data sets. Currently, we are working on loading new data sets and on the other tabs so that we can provide exploration of data sets, objects, and proposals. We're making major enhancements to the user interface to simplify, personalize, and wrangle data. Some of these include sky views and customizable summaries of any selection that you have made.